Good morning, everyone. Am I audible? Voice is clear? Yes. So let us start. Yesterday, at the end of our class, just we discussed about the situations, special situation especially. So once again, I will remind you that situations, what happens if parallel beam of light rays incident on a convex lens. So behavior of certain light rays when they are incident on a lens particularly. So particularly here we can select a fixed light rays parallel to the principal axis, along the principal axis, passing through the optic center, passing through the focus, right? So these helps us to draw the ray diagrams easily by knowing the behavior of light rays after a refraction. So here look at situation one, that is here ray passing along the principal axis from any lens along the principal axis. So here, if a ray passing along the principal axis after the refraction, it remains undeviated. See here, blue color light ray is taken along the principal axis. After refraction, that means passing through the lens also, it remains undeviated. No refraction takes place in this case. So it is given in the figure number 9a. Through concave lens also the same thing happens, that light ray remains undeviated after refraction. This you can notice, right? Then situation 2 is here. That ray passing through the optic center or the pole of any lens. So here in this case also that light ray remains undeviated. A ray passing through the optic center or the pole after refraction or after passing through the lens, it remains undeviated. Then through a concave lens. In this case also, we notice that light ray remains undeviated after passing through the concave lens through its optic center. So these are given in the figure number 10A and 10B. See there, right? Then next ray is situation 3, that is ray traveling parallel to the principal axis of any lens, right? So here center of curvature is identified, then you need for focal points, right? Everything identified. So here rays are parallel to the principal axis, and also I used along the principal axis. So along the principal axis remains undeviated. Then another rays parallel to the principal axis after refraction, they are going to be converged at focus in case of a convex lens, right? So this point only we are given as focus for that convex lens. Then here in case of concave lens, here if parallel beam of light ray that is parallel to the principal axis incident on a concave lens after refraction, they appear to diverge from the focus. If you draw backward rays, they can meet or they appear to diverge from the focus F1. So this point is called as focal point of that particular lens, right? So situation 3 is completed. Situation 4, it's conversion, right? So here they sent actually parallel to the principal axis. After refraction, they are converging at a point. If you send that light rays changing its direction reversely through focus onto the lens, what happens? So here they become parallel after refraction. This we are going to observe in the next situation. So situation number 4 is simply that light rays are passing through the focus, right? So in case of convex lens passing through the focus, in case of concave lens appear to join or meet at focus, right? So here in case of convex lens, double convex lens, you can see that the rays passing through the focus, right? Diverging light rays we can take from the point they are separated. So these light rays are called diverging light rays. So they are focused on the convex lens. After refraction, they become parallel to the principal axis. Right? Then in case of double concave lens, here you can draw that everything. Then here, take the light rays, which they appear to meet focus. Like this. So after refraction, they become parallel to each other. They become parallel to each other. So these are the situations. So from this, we are moving to a special situation, that is here. Simply what happens when parallel rays of a parallel light rays, but they are not parallel to the principal axis, right? In the previous case, we are taken parallel to the principal axis, situation 4, but in this special situation, that parallel light rays making angle with the principal axis. So here look at that, how they are. Simply, we completed all the terminology in the diagram. Then take the parallel light rays that which are making angle with the principal axis. So look at that. Here these light rays are going to make certain angle with the principal axis. So here, do you know any light ray behavior in this case? Anybody? Any light ray meets situation 1, 2, 3, 4? Any of situation? See here, 5 light rays are given. Among these 5 light rays, any one of light ray meets the situation 1, 2, 3, 4, any situation. See here, that blue color light ray, how it is passing. Am I audible? Just respond. How this blue color ray targeted on the convex lens, focused. Pole or optic center. So here, what is your situation number 2? That what happens if a ray passing through the optic center. So in this case, we noticed that remains undeviates. So what I will do, just I can take a scale, then extend that ray without any deviation. Is it clear? It is situation number 2, right? Figure number 10A, 10B. Look at that in your textbook, page number 66. Is it clear, everyone? Go to quick reaction. Are you following your textbook? Page number 66, figure number 10A, 10B. So I got one of the ray. Then here I don't know, because here I have remaining 4 rays that which do not meet any situation among the 4. Is it clear? In this case, what I am doing here, so I am doing just drawing a perpendicular from the focus. So it's F1 towards right side. So focal point. At that place, I am placing the scale like this, perpendicular to the principal axis. I am drawing a line, dotted line. Right? So this line, what is drawn through the focus, and it is perpendicular to the principal axis. That line we are calling as here focal plane. Right? What is actually focal plane? Focal plane is nothing, a line drawn vertical to the principal axis passing through the focus. That we can call it as focal plane. Are you clear? What is focal plane? Is it clear? How to draw? At F1 only we are drawing for any lens, because it is only focus, right? So here I completed that part. Then what to do? Here I can identify that undeviated light ray which passes through the pole or optic center meets the focal plane. That point I can identify. So this point is now I can consider as imaginary focus. So after refraction, that light rays are going to meet each other at that common point. Why, sir? Why, sir? So here, just look at just look at, I am observing this is I's imaginary principal axis. This red color line drawn now, right? So this is what for me? Imaginary principal axis. I imagined, right? Then how these light rays are 1, 2, 3, 4. They are parallel to the principal axis. Yes or no? Is it clear? So they are going to meet a situation that is number 3. Situation number 3. So according to the situation 3, after refraction, that all the light rays are going to be converged at a common point called focus. So in this case, that point I am taken as imaginary focus. So that's why all the light rays which incident on the convex lens making angle with the principal axis converged. So that point is imaginary focus. Is it clear? It is very, very important for solving the example 4 and example 5. If there is any confusion, ask me immediately. Otherwise, I will go for next one. Everyone clear? Go to quick reaction. Everyone. Kaushik, Tejaswini. Right. So now I'll move to the another lens, concave lens here. So here I'm showing you how it behaves. See here, I'm moving the parallel beam of light ray. I'm moving the parallel beam of light ray. So here, in this case, what I am noticing here, is there any change in the converging point except this line? Are you able to see the converging point of light rays when I rotate this parallel beam of light ray? Here I am rotating that parallel beam of light ray up and down to the principal axis. So here always that point is located, that converging point is located where it is on the focal plane. Is it clear, everyone? That what I explained in the previous diagram? Have you seen how that parallel beam of light ray is lying on the focal plane? That's why it is called as focal plane. Always that focal point will be on the line which you drawn perpendicularly passing through its focus. Then let us move to the next one. Another type of lens I am going to take. Here that lens is what here? Double concave lens. So if you focus that parallel beam of light ray which is making angle with the principal axis on the concave lens, that we will notice, observe here. So here, look at that. Concave lens is taken, then identified its center of curvatures, whole focal points, right? Then what to do? Instant light rays, parallel beam of light ray and making angle with the principal axis. So what to do in this case? Anybody? Anybody? First, among these, any situation can you apply for among these 5 rays, for any ray? One of the ray is passing through the optic center of the lens. Is it clear? One of the ray passing through the optic center. So I know the behavior of that light ray. What it is? Undeviate, remains undeviate after refraction through any lens, right? So here I can put the scale, right? Then I can extend that light ray in forward direction after refraction. So here, what I required here, now this line behaves as a imaginary principal axis for me, right? This line behaves as a imaginary principal axis for me. So here that light ray is looking like along the principal axis. That light ray incident on the double concave lens along the principal axis, right? Clear? So here, now this is as imaginary principal axis for me. I want focus on this imaginary principal axis, where it will be. Can anybody identify the principal axis, focus on the imaginary principal axis? I want focus for that double concave lens, where it will be left side or right side. Answer me, don't be silent. If you are silent, I'll think just you are unable to understand. Where the concave lens focus will be, left side to the lens or right side to the lens? Is it a jet? Left side. So here, how to locate that focus? By drawing the focal plane. What is focal plane? A perpendicular drawn to the principal axis passing through the focus, right? So here I can use my scale like this, then I'll draw the line, perpendicular line. So where they coincide, that point will be taken as imaginary focus. Did you see that point? Where it is? Here it is, right? So this point will now act like imaginary focus. You can name that also as something F0 or whatever it may be. See here what I did. Just I connected point of incidence with the imaginary focus. Why? Can anybody give me the reason why I connected them? Imaginary focus and the point of incidence. Why I connected? Because this type of lens is what? Diverging lens. After refraction, that light rays are going to be diverged. Then what to do? Just you have to put your scale, right? Along these line, dotted line which you drawn. So here I'll show you that line with the black color. So here like this, you can adjust your scale, right? Then draw your light rays along these dotted lines. Can you see how I drawn? See them. Look at once again. From the focus, I am connecting that point of incidences with the dotted lines, right? Then I am extending that same line another side to the lens to get the refracted light ray path. Are they diverging or converging after refraction? How they are? Is diverging rays or converging rays? No one answering. So maybe you are in confusion, right? So once again, here look at that. What happens if you incident parallel beam of light ray on the concave lens, making angle with the principal axis, right? So here that rays, here for the both I am given this generalization. In case of convex lens, they appear to converge. Here, in case of double concave lens, they appear to diverge from a point lying on the focal plane. Right? For the both, I am given this generalization. So look at here. What happens if I rotate? See here, I'll exactly stop this at here. How do you feel this one? See here. It is now parallel to the principal axis or not? Are you following? Are you following? Have you seen this? I just stopped that animation. It is exactly coincide with the principal axis, right? Now I start that animation again. Look at that rotation. So here when it is rotated, always this diverging point will be lie on the focal plane. Is it going to change its position other than focal point? No. For any angle, you are just turning that. For any angle, it is always lying on the focal plane. Then look at right side, that refracted light rays are diverged, appear to diverge. Is it clear, everyone, now? What I explained by the drawing? Have you seen? This you have to imagine actually, right? This you have to imagine actually. So this is helping you to draw. It helps you to draw example 4 and example 5 figure problems. Actually, figures only given as problems in the example 5 and example 4. Is it clear, everyone? Go to quick reaction. Shall I move from here? Yes, yes. Rohit, any confusion? No response. Okay, maybe you are not in front of the screen. So let us go for another topic here. That is rules to draw the ray diagrams. So now we are entering into the topic, ray diagrams concept. So before going to that concept, we need to learn ray diagrams, how to draw ray diagrams, which rays, generalized rays, helps us to draw the ray diagrams easily. So this is the reason why we learned the situations to draw the ray diagrams. Why we are drawing the ray diagrams? To explain the characteristics of the image formed by the concave lens or the convex lens, right? So here I'm moving to this topic. So here for any lens, I'm not showing you a particular lens. Here maybe I will take a particular lens, convex or concave, but for anything you can follow the same rules, right? Don't be fixed for one lens. It is for any lens, concave or convex. Here for explanation purpose, I am taking convex lens. Is it clear, everyone? This rule is applicable for concave or convex, right? Just blindly follow my rules. Then easily you will get the characteristics fixed, no change. Blindly you will get, without by hearting, without remembering, right? Without any logic. So what are the rules? First of all, you have to draw a line on the paper, taking that paper landscape mode horizontally, right? First rule is using your paper horizontally, then draw a line horizontally, right? Then at middle of this line, exactly midpoint of this line, draw a lens, whatever it may be. So horizontal line is principal axis, then vertical line you drawn, that is acting like a lens. So you can make it any lens. I made it convex lens. I made it convex lens, right? Then identify its terms, what they are, polar, right? Then for identifying the focus or the center of curvatures, I will show you one logic here. That is, see here how I am using my scale, right, to identify the focus, right? So here exactly they will be located at equal distances, right? Exactly they will be located at equal distances, right? So here, first of all, before going that, I'll give you one of the logic. What are the various places possible here, right? So here, this is object. Vertically, I am showing always above the, right, above the principal axis. So this is top of the object. That point you are selecting. That point you are selecting. From the top of the object, at least you required two light rays. One is parallel to the principal axis, and the other is passing through the optic center of the lens. Second ray is passing through the optic center of the lens. These are the two rays we are using for any lens and for any position of the object. Okay, so fixed rays. No R1, no R2, no R3, only two rays. One is parallel to the principal axis and the other is passing through the optic center of the lens for any position for any lens. Then what to do? Just here you have to complete that generalized rays after refraction, how they behave. So parallel to the principal axis, incident on a convex lens that will be converged at a point called focus, right? And the second ray that passing through the optic center remains undeviated. So here that is, if it is does not meet second ray, then you have to extend it to get a common point coincides where they coincides after refraction. That common point will give you image of the selected point on the object. So what point you selected? Top of the object. So you will get the image, top of the image at this point. So from there you have to draw a perpendicular onto the principal axis. That is called as image here. So this will be object, this will be image, right? So you can write the characteristics by taking here comparison between object and image. So compare the facing direction of object and image direction. Both are oppositely faced. So image is inverted, right? Then you will get that image by actual converging of light rays after refraction. That image is real image. You need a screen to see this image. On the screen, at this point, you have to put. Okay, then next, inverted image, real image. Then what is its position between F1 and C1? What is its size? Smaller than object. So diminished. So like this, we are predicting the characteristics of image. Is it clear, everyone? Rules to draw the ray diagrams. So I will give you my rules now. These are the rules which are given in your textbook, page number 67, right? I will give you my logical rules now. What they are? Similar, but just logically. Okay, for understanding the characteristics without memorizing, right? So here what they are. For that, here logical rules to draw the ray diagrams for image formation by lenses. Okay, don't write if the question come in your exam, what are the rules to draw the ray diagrams? What we discussed previously, as per your textbook, this only you have to write in your exam. For drawing purpose, I am giving you this logical rules, right? So here, first of all, you draw a line by taking scale like this horizontally on the horizontal paper. Okay, then draw a line using your pencil as you see on the screen. I drawn a line on the screen. Then what to do? Just at middle, you have to identify its pole at midpoint on the principal axis, right? So I drawn a lens, identify the pole. Then for identifying the focus and center of curvatures, either sides to the lens, I am following one logic using the scale like this, right? I used 8 centimeter distance left side to the lens. Have you seen the gap clearly? Have you seen the gap clearly? How much I am taking, right? So I taken 8 centimeters exactly, dividing that equally 4 centimeters, 4 centimeters. So at 4 centimeters, I will identify a point, right? At 0 centimeters, again, I am identifying one more point. Then the 2 points are what for me? Focal point and center of curvature. I'm moving right side. That side also I'm using the same distances, 4 centimeters, 1 point, and at 8 centimeters, another point, right? So these are taking, guys, here simply center of curvatures and focal points respect to the lens. Clear? Is it clear? Don't change the gap here. 4 centimeters, 4 centimeters between any two. C to F2. Same, beside, it's beside only. F2P, 4. P to F1, 4. F1 to C1. Same. P to C1, 8. P to C2, 8. No change in the gap. Every side you will measure the same gaps, right? So this is logical thing. Then another logical point is here. that is taking the object. Always it is above the principal axis. There is no doubt. Wherever you place the object on the principal axis, just you need to follow one logic, taking the height of the object exactly equal to the width of the scale. No change in that height. Okay. In your examination, nobody can measure, right? So always you need to follow this logic. Height of the object must be equal to width of the scale. Why? To draw the parallel ray easily, right? From the top of the object, I'm drawing the parallel ray. See here, without removing the scale, I completed two things: object and parallel light ray. This is the logical rule. Then what to do? Use that scale to connect the top of the object and pole. Then draw it. We know the behavior of this light ray. Don't remove your scale. Complete that, right? So any method you can follow. First of all, if you want to complete that first one, you can complete. It meets the focus after refraction. Second one remains undeviate. Clear? Like this, I can get. See here, I got exactly. So here you have to identify that converging point of refracted light rays. That is the image point. From there, you need to cut one perpendicular onto the principal axis from the converging point of refracted light rays, right? Then this is your image. Is it clear, everyone? What I am following the logics, right? This will help you in the ray diagrams. This logics will help you in the ray diagrams, right? So now we will enter into the topic. What are the various possible positions to place the object on the principal axis for any lens, right? So here we will identify the positions first before drawing the ray diagrams. What are the possible positions to place the object on the principal axis? So here, first of all, I am drawing a principal axis, right? Then identifying its pole, identifying a type of lens, just a represented lens, then its respective focal points and respective center of curvatures. Okay, for any position, this is must with the previous logics, 4 centimeters gap, right? Then where you can place the objects on the principal axis. So I will come from very far. What is very far distance from the lens? It is
Infinity.
Infinity. Unable to measure, right? So that distance is what? Infinity distance. Beyond the center of curvature, very far, that is what? That is what? Infinity distance. So we can call that position of the object as at infinity. In such case, I cannot show the any object. Just I will take only parallel beam of light rays. Is it clear? Then next position. Beyond the center of curvature, very far. Beyond the center of curvature, somewhat near. So here, in this case, I can represent the object as you see here, beyond the center of curvature C2. Have you seen the object? It is exactly width of the scale. So in this case, we can call the position as beyond the center of curvature. So we are representing object placing above the principal axis, just outside the center of curvature. C2 here, sorry, C1 written. This is C2. Okay, then next position, onto the center of curvature. So at C2, then it is called as simply object placing above principal axis on C2. Right? Then next position is coming inside to the center of curvature. So it is between F2 and C2. Then you can call that position as object showing between C2 and F2 or F2 and C2. Next position, onto the focus, right? So here object at F2, then here you are representing that object here on the F2, above principal axis on F2. Then next, inside to the focus, between pole and focus. So here between P and F2, then the object above the principal axis drawn exactly between them, P and F2. Are you clear about these positions? Are you clear about these positions? So why we got 6 positions actually? Here, look at why I got 6 positions. Here, I know 2 points from one side of the lens, right? So here, exactly these are the 2 places to locate, and these are called between. So any distance in between them called between, then outside, and very far we can take it as infinity. So 1 2 2, this is, then 3 4 5 6. Any other possibilities wherever you move the object other than these situations? Will you get any other position wherever you maintain the distance from the lens, whatever it may be? Does it mean any position other than these? So are you clear about these possible positions? It may be concave lens also. It may be concave lens also. Is it clear? Right. So now I am ending this meeting. Join immediately in the next meeting.